Welcome back, class. Today we're going to be doing Chapter 2-3A, Combining Like Terms. This will remind you very much of a lesson we had in Chapter 1 when we were subtracting integers. Like terms will have exactly the same variable factors. If you look in the left-hand column, you'll note that they point out what are considered like terms. -5 and 8. Now, those are just integers. In math, we actually call them constants. But you'll notice that if it's a plain x, those are like terms. However, if they're x squared, those are different and like terms. And xy, which is a product, is also considered a like term. Over in the right-hand column, they're kind of showing you that if you have an x but a constant, those aren't like terms. Even if you have different variables like x and y, those aren't going to be like terms. If you have x squared and a plain x, those are not like terms. And the same thing with a variable and a product. Those are not like terms. When you are adding or subtracting like terms, you are really called combining them. Even if we're subtracting, we still call it combining. And this is always done by adding or subtracting the coefficients. And that is really your key today, that you add or subtract the coefficients. So we really look at finding our like terms, kind of grouping them either mentally or on paper, adding or subtracting their coefficients, looking for constants, either grouping them mentally or on paper, and then adding or subtracting our coefficients. Let's look at sample A. We have 5m plus 9m. We have two terms here. They are like terms, m's. According to our key concept thing here about adding or subtracting the coefficients, I add the 5 and the 9 to get 14, but I don't forget to write my m too. So for B, I'm going to add the 4 plus the 7, and then don't forget to bring along the x. A variable may not always have a coefficient in front of it. In this case, the coefficient is what we call the understood one. Sometimes it's referred to as the unwritten one. For example, n is the same as 1n, and the opposite of x times y is the same as taking -1 times x times y. If I look at example C, I have C minus 5. What I really have is 1c minus 5. You're also going to find out that in most cases, it's really helpful if you think of subtraction as adding the opposite. That will really help you to add or subtract these coefficients. 1 plus -5 is -4, and then make sure you don't forget to write the c. If you would like to try the next three, hit pause and then I'll go over them. For D, I'm going to change it to add the opposite. And I'm actually going to kind of insert a 1 there because it just helps me a lot. Now I'm going to take -1 plus -7. That's -8 and x. A plus A really means I have 1 plus 1, so that's 2a. In F, I really have 2 minus 1. Now here I don't necessarily rewrite, although some students do, and they'll go ahead and they'll put an addition sign in there, and then they'll insert a -1. Now if that's going to help you to get it right, I would suggest you do it. 2 plus -1 is 1. I'm not going to write that. I'm just going to leave this as AB. There are a lot of examples here, and if you want to work through G, H, I, and J, hit pause, and then I'll give you the answers. In G, I'm going to hit the add the opposite, and I will have -15t. Now in K, you could go add the opposite to add -3. But in my mind, I'm thinking 8 minus 3, and that's pretty early elementary math. So I don't usually change that. If you want to, though, you may certainly do so. In I, 7 plus negative 7, excuse me, plus 2 is going to be negative 5, and I'm going to have negative 5xy. In J, my answer is going to be 4ab, because negative 3 plus 7 is 4. Looking at K. K is an example of where I'm going to put more than one type of term in the same expression. Now remember, it's only the like terms that combine. Now here's where you have a choice of either doing this mentally or writing it out. And if it helps you to rewrite it, go right ahead. I'm going to use my commutative property and interchange this 4 and 5x. I'm going to rewrite it as 3x plus 5x plus 4. Remember I told you at the end of chapter 1 and even the beginning of chapter 2 that that commutative property is extremely powerful? This is why. If you can commute those two terms and put them closer to each other, it's a little easier to think about them and combine them. So now I'm going to get 8x plus 4. If you'd like to try L, go right ahead and I'll explain it. If you would like to rewrite it, I'm going to also change this to add a negative. So I'm going to get 4y plus negative 2y plus 5 plus 4. That gives me 2y plus 9. If you'd like to try m and n on your own, you're welcome to do so, and I'll explain them. In m, I see those subtractions, and I'm going to change them to add the opposite. And I'll insert a negative 1 here. Now, in this one, I am going to do some commutative property as well. I am going to take 4y plus negative 1y plus negative 2p plus 6p. Now again, you can do that mentally if you want. I'm choosing to write it out for this particular lesson. Generally, we prefer if you would do it alphabetically. So I'm going to look at this negative 2p plus 6p, and that is going to give me 4p. Then I'm going to look at the 4y plus negative 1y. That's going to give me a 3y. For n, this time I'm going to do it without rewriting. Add the opposite, add the opposite, add the opposite. Negative 5m plus negative 8. Now here's where it gets a little bit more complicated, because we don't usually like to leave things as plus negatives in an answer. We're going to change it to 5m minus 8. What it comes from is, remember back when I said, look, if we had n minus 2, that really equals n plus negative 2. So this can actually go to this. Look what we have in example n. You have negative 5m plus negative 8. Just like n plus negative 2 is really n minus 2, that means that negative 5m plus negative 8 is really negative 5m minus 8. And that concludes this lesson 2-3A.